Hey everyone, sorry for the interruption. Hopefully I didn't lose too many of you. All right, let me go ahead and show this again. So for those of you that missed what was happening before, in this stream I will be working on implementing locality optimized search for a lookup join for an anti-join specifically. So an anti-join is a case where we have select star from A where not exists, a subquery where we have another table that joins with the outer table. And we can be pretty confident that it's going to be a lookup join when one of the sides of the join is very small. And we can ensure that by restricting it to, say, a single value. So in this case, we've restricted A, say that X and Y are both key columns in each of these tables. And we're restricting that key column to 1, which means that we just have a single row in A. And an anti-join works by basically looking up into the other side of the join. If a row exists that matches the join condition, so remember this join condition is b.x equals a.x. So if that row exists, then the join returns nothing because it's an anti-join. We have this where not exists clause here. If the join exists, we return nothing. If the row does not exist, then we return the left-hand side row. So for this stream, we're particularly interested in the case where we have a multi-region table. So say part of the table is going to be in one region, let's call it east, and one part of the table is going to be in one region west. And since the join condition doesn't include region, we need to actually check both regions. We need to check both east and west for this join condition a.x equals b.x. And if we find the row in east, because this value is a key, we know that this is going to be the one and only instance of that row. Then we're done. We can just return. The join returns nothing, and we haven't needed to visit this other region west. If we don't find the row, that means that the join will return this value from A, and then we can use that to look up into B, into the region west. Okay, so hopefully that's clear. Please feel free to ask any questions in the chat. All right, so now let's go ahead and implement this. I am going to open up the branch that I started with a kind of a related fix. So and I'm going to leave this branch as is and create a new branch. So let's call it locality opt anti-join. Okay. Great. So now we can look at what we already have here. This is something unrelated. Okay, so this is going to be in X form, and we should already have a rule in join. So this is a previous iteration of what I was trying to do with locality optimized lookup join. And but this isn't really going to work. So I'm going to just copy it and let's call it locality optimized anti-join. And it's going to match when we have when we have an anti-join. So let's update this function, can maybe generate locality optimized lookup join, and change it to anti-join. And this is going to be, I think actually what I'm going to want to do is I think I'm going to want to actually construct a couple of lookup maybe that's too complicated. I don't know. I don't know if I can directly construct, well, maybe I can. All right, so let's see. I'm going to be constructing one lookup join that is going to have the same original input, the same on condition, although I think we'll want to make sure that this on condition is basically empty. So we don't even need to create a variable for it. And we're going to create a lookup join private. With what I'm going to return from this function. So let's just call this generate locality optimized anti-join, and we're going to check if it succeeded. And it's going to take on the value of local and remote filters. Local and remote lookup experts. And so succeeded is basically going to check that this is not nil, because if we can't generate a locality optimized anti-join, then this is going to be nil. Okay. And then this is going to basically get the local filter, the local lookup expert from this thing. And this is actually going to be the inner lookup join. So the outer lookup join is going to, now this inner lookup join is going to be input. And once again, we're going to have empty on conditions. And we're going to create the lookup join private. From the remote lookup expert. Okay, I thought that would reformat, but it's probably because I haven't built the op formatter. So let's look at what's in bin. Yeah, I don't see op format. So okay, so make all right, any questions in the meantime? Doesn't look like it. All right, now let's try to make some changes and save this again. Oh, that didn't really work. Okay, let's check what our file watchers are doing. Ah, I don't even have it checked. Okay, apply. Okay. All right, now you can see it's running file watcher. Oh, it didn't like. Didn't like something. I must have some mismatched parentheses. Let's try that again. No, still mismatched. Okay. This is, oh, okay. Yeah, I think I need one more. Is that right? Oh, okay. Yeah, I'm missing one here. Okay, and that is going to be the inner lookup join, and this is the outer one. All right, now let's try to save. Still doesn't like something. Okay, I have 1, 2, 3, 4 open parentheses, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. We have something messed up here somewhere. There's create. There's the lookup join. Okay, this is unnecessary. Try this. There we go. All right, now you can see we have this nicely formatted expression. And if only it would tell me where my parentheses were in the wrong place. Okay, so now we need to actually implement all of these functions that do what we want. All right, and I think I want to call this anti-lookup join private because we're making an anti-lookup join. Okay. Let's implement this function. Okay, so I want to take this function and repurpose it. So I'm going to be combining these two functions. So all right, let's just YOLO, go for it. So this is going to be generate locality optimized anti-join. And it's going to check a few things. Oh no, maybe we don't need that group. We need the private, but that's already included here. So we're going to need the input expression at least. Let's see. So We're going to need the input private. And we don't need to worry about this, right? Oh, actually, let's do a make build short, just so we don't have these errors that it can't find these different things. Okay, question from somebody. So .opt is a generated file from CRDB. Great question. .opt is it's not generated, but it is used to create generated files. So let's look at the generated file for this join.opt function, or this join.opt file. Actually, we're currently building, so we won't be able to actually look at the generated files just yet, but I will show that when it's ready. Okay, in the meantime, I'm going to be working on, all right, so we don't want to run this if locality my search is false. We also, well, maybe I do want that. Let's just leave that for now. Okay, looks like it built successfully. All right, we're just finishing building right now. But in the meantime, we've generated all of the files, so we can look at this now. So we're looking for generate locality join. Actually, I can probably see where yeah, there's going to be errors, so we're not going to be able to show that the generated file from join.opt. But this is a generated file that comes from a different .opt file, so you can kind of see what it looks like. Yeah, it just looks like regular Go code, but there's all of these conditional statements here that would be pretty annoying to write if we didn't have a code generator that built them for us. So it's the generated files from the .opt files are the .og.go files. And those are not checked in with Git. They get built as part of the make build short command. Hopefully that answered the question. Okay. Okay, so actually I'm going to undo this for now because I don't want to, no, I don't really want to lose these functions. So instead what I'm going to do is just copy them. And I'm going to basically combine them into one function. And it's going to be generate locality optimized anti-join. Okay, so this is now going to return something new that I'm going to create, which is going to be this local and remote lookup express thing. So it's going to be one of the limitations of opgen is that we can't return multiple expressions like we can in Go. So instead, we're just going to return a single struct. So this is going to be a type called local and remote lookup express, very specific to exactly what we want, and it's going to be a struct. And it's going to have local. This is going to be, what is actually, okay, so again, you can see this is a generated file. It's going to be a filters expert. And remote. Okay. Oops, spelled that wrong. And this thing is going to return one of these. And I think I'm going to just make it a pointer to one of these because that will allow us to check if it's nil or not and know whether this function succeeded. So instead of false now, in all these places, we're just going to return nil. And basically, this is going to be if not found, we return nil. Okay, so we're getting there. What is this returning? Oh, once again, nil. Okay, so we're not going to actually have access to the group, but I don't think that we need that. Any questions that I missed? Oh. All right, so instead of checking whether the cardinality is 0 or 1, instead what we want to check is whether the lookup columns are a key. So that is going to be in our private. If we can't guarantee that lookup calls are table key, then we're not going to be able to perform this optimization. Although actually with anti-join, I don't think it really matters. Let me just leave this as a to do. And I'll need to update this comment, but I can do that later. Okay. So now we've got a lot of return statements we need to fix. Return nil. Return nil. Okay, and we decided that we're not going to apply this if, okay, actually all of this stuff is going to change, I think, down here. What is, guess Chrome is using a lot of activity, but it's okay. What happens when you stream? Okay. So it thinks this tab meta is not getting used. Where would I have been using that? Where does it get used up here? Oh. Ah, I've already done that up here. Okay, there we go. Let's get rid of that. Yeah, it's exactly the same thing. Same here. I've already found the index. Okay, we're going to have to update this because this is still assuming that there's two different functions. But oh, these are not spans. These are values. So I think actually we might not need all of this stuff. So the main thing that we're trying to do is we're basically replace this lookup expert from the original lookup join with a new one that contains just the expressions targeting local nodes and then just the expressions targeting remote nodes. So to do that, we're going to return one of these new structures that I just created. Local and remote lookup experts. And the local expression, it's going to do something similar to what I did here. No, I think I want to create this first. So local expert is equal to basically I want to copy private.lookup expert. So I need to make a new filters expert. And I want it to be the size of private.lookup expert. And then I want to copy. And now I'm going to specifically set this filter index in the local expert to make const filter. And this column should actually be right because I no longer want to map the columns. What I was doing before was required that I basically created new values of every column in every table and mapped them, but I don't need to do that anymore. So, okay, that looks good. And I kind of want to do the same thing for the remote values. Okay, and then we're assigning the local expert here and the remote expert here. Now, I think I can just get rid of all this other stuff that I did before, because this involved creating a common table expression and using it in 2 different copies of the join. And I think all that stuff is just unnecessary now. Well, I can delete it because I have another function that I've saved just in case. Okay, any questions about what I've done so far? I don't need this table apparently. Okay. I want to check what this succeeded function does and check that it actually does what I think it will be doing. If it even exists. Maybe it doesn't exist. I know there is something. Let's see if I can find it by using the Go autocomplete. I see. Succeeded has to take an opt.expr. Oh, but okay. In another place where we've done this expr pair succeeded, we just defined it as special custom func. So let me go look at that function and try to copy it. This looks pretty straightforward. Oh, well, I guess in that case, we wouldn't be returning nil, we would just be returning an empty one of these objects, which maybe that's actually better. So we'll replace nil with an empty one of these, local and remote. And now instead of returning ampersand, we just return. And this is going to take Why doesn't it like that? Operator not equal is not defined. Well, that's strange. Very weird. Why does this not work? Let's see if anyone on the chat has a smart idea. No. Well, let me just try to build this and see. See what happens. It might be Golan just being weird because I don't see why this wouldn't work. Okay, well, it's complaining about some other things. So let's make this function now. Create anti-lookup join private. And what does this take? I need a function that selects the local lookup expression. So that's going to take this thing and return local. I need to return a filters expert. And same thing with the remote. Marcus sent me a Slack message explaining, since slice types are not comparable in Golang, your struct is not comparable because it has two slice type fields. Awesome. Thanks, Marcus. And Okay, so I guess what we instead need to check is dot local is not equal to nil, and dot remote is not equal to nil. Or I guess I can just check the line. Okay, and dot local not equal to 0, and length of is not equal to 0. Okay, so we are just about out of time. So I'm going to end the stream here, but thank you all for tuning in, and sorry for the technical difficulties. Thanks for bearing with me. Have a good day.